Now I want you to pause the video cast again and predict what the approximate wavelengths will be and some of the uses. Okay, so the range of wavelengths then initially. They range from 1 by 10 to the minus 12 metres for gamma rays, right up to a metre or a kilometre for the radio waves. Now what does this mean? Well, let's remind ourselves lambda is wavelength. And what does the term wavelength mean? It's the length of one complete cycle. For example, if we use the sine wave as an example, that one complete cycle, the wavelength is from the starting position to the finishing position. And for gamma radiation, that is 1 by 10 to the minus 12 metres. And that ranges up to some of the longer radio waves. The length of that wavelength from the start to the finish of the wave can be a kilometre. So there's a vast range of wavelengths. Uses then. The gamma radiation is used in cancer treatment. And most of the waves in the electromagnetic spectrum find uses in medical applications. X-rays are used in medical imaging. Ultraviolet used in sun lamps and for exposing PCBs. You may have done that in technology in the junior school. Light, the visible spectrum, if we call that visible light, it's used for a whole range of different applications, including photography, for fibre optics, for communication, and also within medicine. In terms of the communication, the fibre optics can be used to transmit TV signals, telephone, internet, broadband, and so on. And they're used also in fibre optics in medical applications in terms of the endoscope to examine organs. Infrared radiation then. It's used in your TV remote. So you're using infrared, I would think, every day in life. So it's used in your TV remote control. It's also used in fibre optics for communications. Again, that's your TV, internet, telephone. And it's also used in heat lamps, maybe to treat muscular injuries. Microwaves. Well, obviously you have your microwave ovens. That's the first idea that jumps to mind. But microwaves are also used in mobile phone technology to transmit signals and also for satellite television. And radio waves then are used for radio communications and also for television. In terms of the electromagnetic spectrum, we did mention those wavelengths. And the wavelengths can be represented in terms of size with these different examples. Atomic nuclei are approximately in the range of size of gamma rays. X-rays, the wavelength is approximately the size of an atom. For ultraviolet, we're talking more about molecules. Light, the wavelength of light, visible light spectrum, is around about the size of protozoans. Infrared's about the size of a pinpoint. Microwaves, the wavelength of microwave is about the size of a bee. And the radio waves, the wavelength can range from that of the size of human beings to the size of buildings. Can you think of a phrase that would help you to remember the order of the electromagnetic spectrum? You must learn the order: gamma, X-rays, ultraviolet, visible light, infrared, microwave and radio. One example could be gate X usually lets in most radiation. And the initials would help you learn G, X, U, L, I, M, R. So gate X usually lets in most radiation. And finally, to summarise, light, a type of radiation, is part of the electromagnetic spectrum. The electromagnetic spectrum is made up of different types of radiation. You have to learn what they are and the order of them. And the different types of radiation then have different properties and behaviour. If you think about the difference between the X-rays and, for example, visible light, you can appreciate how different their properties and behaviour are. The similarity that all the electromagnetic waves have in the spectrum is that they can all travel through a vacuum, and do travel through a vacuum to reach us here on Earth, as space is a vacuum. Also, they all travel at the same speed in a vacuum, which is 3 × 10⁸ metres per second, or 300 million metres per second. And finally, the definition of electromagnetic waves. Electromagnetic waves are a combination of electric field and magnetic field. So they're a combination of electric and magnetic fields. Now that concludes the light unit. Please now go to the past paper questions, try the past paper questions, and then mark them using that video cast.